All right, welcome to Ops Lecture 4. This is now week 7, and we only have 4 more weeks until we're ready for, I don't know, winter. Yeah, okay. So there's the link for the slides as per usual. It should be available now. Okay. And some events coming up this week. This week is a pretty busy week. So tonight the Idea Hacks applications are due. So if you want to participate in Idea Hacks, you have to get your applications in tonight, I believe. And it's a really great opportunity for you to work on something new, and like given all the resources from Idea Hacks. So do consider. And then this Thursday at 7 p.m., there's the GB info session. GB, as I said, is a great experience, so do come to that. And then there's Project 3, Checkpoint 1 and 2 are due this Friday at 6 p.m. And then there's going to be an IEEE-wide movie night social this Saturday at 8 p.m. And then there's a feedback survey we would like all of you all to fill out, so so we can like improve ops. And then yeah, so there's a link. I believe you should be able to click on it once you get to the slides.
Looks like David just informed us that Idea Hacks application got extended until the 22nd, which is in a week.
Yes, right.
Go ahead and do that, guys.
Sounds like you can take your time, but don't leave it off. Yeah, sounds good. And then, yeah, Checkpoint 1 and 2 will be due this Friday, but we'll talk about that more at the end of the lecture. So GB is a great experience. GB is where you get to meet a small family within IEEE and just hang out with them. It's just like, it's going to be like very chill, not too stressful. You'll get to meet some new people, and they're all going to be great because they're all great. And yeah, join GB. What do you have to say about GB, Ryder? Nothing?
I disconnected for a sec.
Do you have any words about GB? Why people should join GB?
Yeah, because you should come join my GB because it'll be super cool and we'll be like telling each other jokes and having a good time and laughing. I guess you could join Taylor's too, but
wait up. You should come join my GB. So both Ryder and I are gonna have GBs, separate GBs. And the other officers in IEEE also have GBs, and they're all really cool people. So do come out to the info session. You'll get to find all about all the GBs and check out their vibes so you know which one to apply for. Yeah, that's happening this Thursday at 7 p.m. And then Idea Hacks application. Look at this beautiful graphic. Like Idea Hacks is just going to be great. Just look at this. It's so good. Yeah, and then there's the movie night. I believe it's a scary movie.
Oh, it's Knives Out. It's more like a mystery movie, I think.
Okay, never mind. Yeah, do come out and watch a movie with us. Relax for a little bit. All right, now getting on to the real lecture stuff. So previously in ops, we covered circuit analysis with Ohm's law, Kirchhoff's laws, and then we also covered debugging a circuit with the DMM, with the continuity test and all that. And then today we're gonna cover Arduino stuff. So Arduino as microcontroller, and then some pins and functions that you can use with the Arduino. And then we'll have a demo of blinking LED at the end of the lecture. And then we also have some C++ syntax help for those of you who are not too familiar with C++.
All right, so we're going to talk a little bit now about the actual microcontroller. We've used it a little bit in other projects, but now we're going to sort of get into what we can really do with it. So you can think of your microcontroller as a little computer, which you can program to do whatever you want within the confines of what it's able to do. Essentially, all of the pins can act as either input or output. We've just used the source and ground pins, which we can't change, but most of the other pins we can sort of code to do what we want. And we could connect these pins to our circuit and get our circuits to do some pretty cool things. So the Arduino needs 5 volts to operate, but you can put in up to 7 to 12, and that's sort of the maximum output voltage you can get. As you've seen, we have the 5 volts and the 3.3 volts, which will always be constant for you to use. There's a USB port for you to connect to your computer. That's how you upload your code to it. And yeah, all the pins, we can input those into our circuits and get our circuit to do some pretty cool things. All right, so now looking at it, if you have your Arduino with you, it could be good to look at right now. So there's, I think, 3 different ground pins. They're all grounded together, so you can use that throughout your circuit. You have your power supply and then the USB. So you could externally power it with a battery, or you could connect it to your laptop or computer and that'll power it too. The input voltage Vin just is set to whatever voltage is being used to power the Arduino. And then there's a little reset button. And what that does is whenever you upload a code to your Arduino, pressing the reset button will just basically reset it so you get to start from the top. Otherwise, it'll just run continuously. So on the left, we can see some analog pins. Those are the ones that have the A in front of the number. Those are input only, and what it does is it can read a voltage between 0 and 5 volts, and it will map that value to a range between 0 and 1023, which helps you when you're coding. And we have digital pins on the right, and you can do input or output on those, but in general, they have just 2 values, high or low, so we could send out a high value or a low value to our circuit. So this is the pinout. You definitely don't have to memorize this, but this will be good to reference, particularly the pink numbers, because that's how we'll reference the pins when we're programming.
Yes, there are some more details into these pins that we will not get into in this lecture, but you'll get to learn more about it in some of the future lectures in ops. Yeah.
All right, now looking at the IDE. So if you're looking at the slides, you can download it if you guys don't have it already, but this is what it looks like. It it has the same sort of syntax and structure as C++ code. So those of you in CS31 right now should be somewhat familiar with how the syntax should work. And then you can review these links for some of the rules for syntax.
So some things to note is the toolbar at the top, and then there is the section where you can put your code in, and then there is the status message over here. And then if you get any errors or just want to see the status of how things are running, you can see in the bottom part of your IDE. Yes, sorry, Ryder.
So these buttons on the top, they do different things. So the one on the left, the little check mark, is the compile. That just checks to make sure your code doesn't have any errors in it. It doesn't upload it to your board at all. So you can do the compiling even when your Arduino is not plugged into it. It just checks to make sure there's no syntax errors. Then we have the button to the right, that arrow, that actually uploads it to your Arduino. So when you upload it, it'll first do a compilation check. So it'll compile it and then it'll upload it. So that works as a compiling too. And that puts in your Arduino, and then after you upload it, your Arduino should start doing whatever you want. These ones to the right, I think are like, you can open a new one, or yeah, you can open an old one, start a new one, and then save it. But it should save every time you compile the code. And then the one all the way to the right is the serial monitor, which we like to use when we're testing. It just is the monitor that you can print values out to. So you can print messages or values or whatever you need, and it's really useful for testing. Any questions about any of the things we talked about?
So you were saying the serial monitor. So what exactly is that?
Oh yeah, it's a serial monitor. So that's the we'll look at some examples later, but essentially what it does is you're able to print values. So if you're doing if you wanted to print out a message whenever your Arduino did something you wanted to send out, like job is done or something, you could print it out and then you could look at the monitor and that text will pop up when it's supposed to. It just lets you really look at values or any messages that you might want to look through. It helps a lot in debugging or testing in that capacity, but it also works for more functional use if that's involved in your program.
Yes, we'll also get into serial communication in winter quarter, I think. All right, if there's no questions, we'll start looking into how to actually write code in the Arduino IDE. So there are two main sections to the Arduino, to any code in Arduino. If you see over here, there's the void setup and there's void loop. So the first part, setup, that chunk of code runs at reset. And then here's where you declare all the pins as inputs or outputs, or start serial communication, or just do anything that you want to do to set up your circuit or your program. And then there's the loop part, which is the second part. This part loops infinitely. So any code you put inside this section will just like execute over and over and over again until you hit reset, and then the code resets and does the setup again. So here you want to put in things like, oh, getting sensor readings, or maybe printing something out continuously, or putting outputting some voltages continuously, or things like that. Yeah. Okay, so here are some functions we are going to be using. So first of all, digital write. Digital write takes in two arguments. It takes pin and then high or low. It basically outputs high, which is 5 volts, or low, which is like 0 volts voltage to the pin you specify. And then there's analog read. It's kind of straightforward. Reads variable voltage and returns a value between 0 and 1023, as I said before. And the pin you specify inside the function argument is the pin that it's going to read voltage at. Whoa. And then there's delay. Delay is a very useful function. And then delay, if you put the number of milliseconds inside the parentheses, it'll delay the program for the specified amount of milliseconds. So you want to use delay to like blink your LED, or you actually want to place delays throughout the program for everything to run smoothly at the same time and things like that. And then there's serial print and then serial print line. And these are really useful things for just like debugging, seeing where your code is at. It's basically like printing in any other programming languages, but it'll print to the serial monitor, as you saw earlier. So if you open the serial monitor, it'll have everything you print to serial.print. And then the difference between serial.print and serial.print line is that serial.print doesn't put a new line at the end of the print, and serial.print line does put a new line at the end of the print. That's the only difference. All right, so that's all me talking. Let's look at this code and try to see what's actually happening in this code, right? So we have an Arduino program called a POT demo. And then it kind of says what it does over here in the comments section. But what it does is it defines POT as the pin number 5. So pin number 5 can be referred to as POT throughout the code. And then in the setup, I set POT as an input, and then I begin serial communication so that I can print stuff out. Whenever you want to use the serial monitor to print stuff, you have to do serial.begin. And then it obviously prints, here we go, at the beginning in setup, and then it continuously reads value from the POT pin we specified above, and then prints out that value every 50 milliseconds. That's how it looks. Any questions on this? Great question, Matthew. The serial.begin 9600 is the baud rate. It's not an arbitrary number. It's the rate at which bits are transferred to your serial monitor from your Arduino, but you don't have to worry about it. For now, just use 9600. Yeah, and that's usually the value we're going to use. And Enoch, very good question. How does it know the POT input refers to 5? Is because we did hashtag define POT5 at the very beginning of the code. So what that does is it tells the program that we're going to, whenever we refer to POT, we're talking about 5. So usually, if we didn't do the hashtag define, we would do pin mode 5 input. But instead of doing that, I did hashtag define POT5 at the very beginning so that it's easier to remember and also easier to change the pins if I have to in the future. Is there a slide? I think, maybe I got rid of the slide, but Basically, whenever you're using pins, it's better to do the hashtag defines to be able to refer to your pins with some like names that you assign to them instead of referring to them as numbers. Yes, POT is just a variable name. So it's something I can remember, something I will know in the future. If I have to change the POT pin to like say 7, all I have to do now is change the hashtag define statement in the very beginning of the code instead of looking through all of my code and changing all the 5s to 7.
Yeah, and you can refer to the pinout for the values of each pin, but for the most part, they should align with the actual value on the Arduino. It's just the A0 through A5. You can refer to them as numbers, or I think you can do A0 through A5, but you can refer to that on the pinout.
Yep. All right, cool. Any more questions? Okay, and now Ryder is going to go into some possible things that are going to happen.
All right, so let's say we write this code and we want to compile it before uploading it. What are the 3 errors that could come up, that will come up actually, when I try and compile this?
Feel free to type in the chat or yell it out if you're brave enough to unmute yourself.
You're confident.
Yes.
Okay, hashtag define, that's one of them. Yep. Int x, yep. And there's one more,
yes,
semicolon.
Semicolon. Yeah. The semicolon is the most annoying thing, and it will definitely happen. Okay.
All right, so yeah, so just going through them. So the beginning, we need a hashtag define. That's just how you use that. And then we're missing a semicolon after the serial.begin command. And then the last one, which is probably the trickiest one, is that we need to declare int x. Otherwise, it doesn't know what you're referring to with x when you assign the analog read value to it.
And Courtney brings up a really great point, actually. You probably want to put in some delay. It's not going to cause any compilation error, but yes, usually you want to put in some delay. Okay.
All right, so here is another issue that could go wrong. So it's not going to be really syntax related like the other ones, but this is more how we use the Arduino. So what could go wrong here?
Pay attention to what you're using the LED pin for. Yes.
Yep.
Yes.
So we label the LED as output, which means we're going to send out values. And that would also mean that it's a digital pin. And then we're trying to use the function analog read on it. So it's just going to cause all kinds of errors and it's not going to behave. So I guess when you're coding, make sure you know what your pins are doing. Are they taking in an input? Are they taking in or are they giving out an output? So it's important to know what they're supposed to be doing when you start coding.
Yep. And then actually more so than this kind of error, the type of errors you will run across is probably not forgetting to do pin mode. So don't forget to do pin mode.
Right, yes.
Okay.
So now let's say we are trying to write a code and what we want to do is to just sort of print out how many seconds it's been since, we started up the Arduino. So we have this code on the left here and we have the setup and we begin, and then we have it integer x equals 0, and then we increase it at the end of the loop every time. So we delay a second, then we increase it, and then I run it, and I just get it staying at 0 seconds. Any idea why it's not increasing?
Hey,
yes, so
like y'all are this.
Yeah, so the loop starts, it runs continuously, and it repeats every time it goes through. So once it gets through and it adds 1 to x, it'll start back at the top and it'll set x back to 0, making it 0 every time. So quick solution is just that declare and initialize it outside of the loop so that way it doesn't get reset every time it enters the loop again. All right, and then this is extremely common error. This is the #1 error you guys are going to encounter probably. You're just going to try, you're going to put in your code and it's going to compile okay, and you're going to try and upload it and you're going to get an error message like this. saying it had an error uploading it to the sketch. There's nothing wrong with your code, and there's a pretty simple solution to this. So you're just going to go into Tools, go down to Port, and make sure that you have a port selected. If it should just be one there if you have only one Arduino connected to it. So just make sure that's selected, and then it should upload fine.
And then you also want to select the right board. So you don't want to do like Arduino Nano, you want to do Arduino Uno if you're using Arduino Uno. And yeah, selecting the right port and board is surprisingly the hardest part of coding in Arduino. So yeah, be aware that this could be happening. If your code is right, but nothing's working, this could be happening. All right, any questions so far?
Oh, and earlier when that example with where it's printing out the 0 seconds over and over again, that was the monitor. So I clicked on serial monitor, and then that popped up, and that's what it printed it to.
Yes. You can also do Control-Shift-M to pull up the serial monitor if you don't want to move your fingers. Okay. All right, now the project. So project.
Yes.
Yes, writer.
So there's the project's broken up into 3 checkpoints. The first one should be pretty simple that you guys should be able to do pretty quick. We recommend that you get the second one done by this Friday. That'll be about half the work you do. You don't have to get checked off for it, but just highly recommend you get it done by then. So that way you have a whole nother week to do it before next Friday when the final project will be due. And there's details in the spec with what you actually have to show us. So try and not put this off to the last minute, because on that final Friday, we're going to be doing mostly checkoffs, and we're not going to have time to help you from the beginning of this project. So come in early if you're stuck and need help on any of this.
Yeah, and as per usual, you can find us all on Discord. So do refer to IEEE for our officer hours, but this week I have a midterm on Monday, so I won't be there 5 to 6, but I will be there from 6 to 7:30, and then Thursday 5 to 7. And you know how to find us now. Just message us and ask us when we're going to be in the lab, or if you have any questions, you can just like ask the questions over Discord Messenger too. Yeah.
Yeah, and then so in this project, you use a variable resistor. So we're just going to quickly go through that. It shouldn't be too tough to understand. So variable resistors are just what they sound like. They're resistors that can change value. The potentiometer is probably the most complicated example of that. What it actually does is it's more like a variable voltage divider. So within it, there's like 2 resistors in series. And you could turn that dial to sort of shift how much resistance is in one versus the other, while the total resistance stays the same. And that middle pin acts as a V out. So you could change it, and as you vary size of R1 and R2, V out should change if you have the same voltage source.
Yeah, but we don't actually use the potentiometer in this project. You will use it for the future project, and we will do a more detailed lecture on it in the future. So don't worry about it if this is all nonsense to you.
And then we have a thermistor, and this is a resistor that changes value based on temperature. They come in 2 different types. It comes in both ways, essentially. If you increase temperature, it could increase resistance, and it could go the other way. If you increase temperature, decreases resistance. We're not going to use this for any of our projects, and it's commonly used in hardware just to detect if there's a large current, because then it'll start heating up, and it can shut down the device if it's burning up too much. This is what we will be using in our project. So this is a photoresistor. So you guys should have one in your Arduino kits. The way it works is the resistance of this resistor decreases as the light intensity increases. So if you shine a light on it, the resistance should go down. It's pretty complicated sort of physics-wise, and you're going to definitely learn about it when you take EE2 in the future. So don't worry too much about the physics behind it, but just know that when you shine light on it, the resistance decreases.
All right. Any more questions before we start our LED demo? I'm actually going to stop the recording now. No, wait. Yes. Stop